Hello friends, we actually looked at how we can generate the public keys and the private keys. First we generated the private key, and then from there we got the public key. So if you look at what got generated, we can do a cat on the private key. So this is how it looks like, the PEM contents. And if you want to look at public key, let's take a look at that as well. This is how the public key looks. What we'll do is we'll use these pairs to sign with the private key and then verify that with the public key. Okay, so if you go back to our previous diagram, we'll be using the algorithm of RS256 to generate the tokens, to sign the tokens, and verify the tokens. The procedure is the same, it's just that we're using the private key and the public key as our secrets, and we'll be using the algorithm RS256 in place of HS256. Okay, and all the content or the token that gets generated will always be in the same format. Alright, so let's head back to the VS Code. I'll create another new file, this time with JWT pbt key.js. And first I will require in the JSON web token, so const JWT is equal to require JSON web token. Okay. And then I'll have a payload, const payload is equal to, okay, I'll just say message, hi friends. Okay, now that we have the payload, we will get the private key now to actually sign the token. So let's say, I'll just say private underscore key is equal to. So what I'll do is I'll go back to the terminal where I actually catted the private key. I'll do that one more time. Okay, and then I'll take all the contents, copy that, go back to my terminal, and put it inside of two backticks. Okay, so the backticks, the key thing with backticks is that it'll avoid all the escaping of the special characters in case there is anything in the private key. Okay, so that's what we did. Now we go ahead and save this one. Okay, let me save this. And so we got the private key, we got the message, and now let's get the token, which is const signed is equal to, we will call the sign function sign, and then we got the payload, yes, and we got the private key. I think we named it as pbt underscore key, if I'm correct. Yes, we did. Okay, and then we'll specify the algorithm. Algorithm would, in this case, would be RS256, and you can also have an optional expires in, let's say 1 hour. Okay, so at this point what we'll do is I'll just console log this token. So if I go back to the source, I have two files now, and we want to execute the one which is having the logic for public private key. Alright, so if you look at it, and this is the token that got generated, slightly lengthier in my opinion compared to the one that got generated with HMAC, but I could be wrong because I had a relatively smaller window back then when I looked at the HMAC signed token. Anyway, so now that we have the signed token, we can also verify this token, and for that we need the public key. Alright, so I will source the public key underscore key and put the public key under two backticks. Okay, and I'll go back to my Docker terminal window. I will do a cat of the public key, take everything, all the contents, and then essentially put it back in here. Okay, so that should handle that for us. And now let's decode the token. Decode, and for that we get the JWT reference, then we'll call the verify method on that, and for that we need the sign. We want to give some data to that, which is going to be the signed data, and we'll also need the secret. In this case it's going to be the pub key, which we just sourced in the previous line. Excuse me, it's not public key, it's pub key. And we'll also specify the algorithm, right? And in our case it was RS256. Okay, let me quickly console log this part. Console log decode. Right, so let's re-execute this program and see. I think before I do a console log, I just want to quickly put a new line so that the output is actually coming in a clean and neat format. Just put a couple of new lines. Alright, so that's better. Okay, so let's quickly execute this. Alright, throw error. It doesn't. Okay, something went wrong. I just did not do it correctly. Okay, there you go. So we passed a message called hi friends, and then after essentially deconstructing it, or if that is the right word, verifying the token, a signed token, using the public key, we got back the same content. Okay, so this is how it's going to be. And another thing that I want to check right now is that I'll take this token, okay, and put it back in the debugger website that we just went to. So if I go here, paste it in, so it gives you back the exact thing, right? And if you want to verify that, so I can put in my public key here to verify that. Let me see where the public key is. This is the public key. Okay, let's see what happens here. So yeah, it says the signature is verified. Okay, so if I change it for some reason, it should actually do something. Okay, alright, if I change it, yeah, it says invalid signature. If I don't give the correct public key, it actually gives a invalid signature. Alright, so and then also if I, let's say, instead of B I put A, it should also give me an invalid signature. Yes, it does. Okay, let me go back. Signature is verified. Okay, so that's about it. Thank you. I hope you liked it. Great going.